Similar triangles are when we have two triangles with the same shape. And what I mean by same shape is that there's equivalent angles, equal angles, but at different size. So the sides are not equal. Sides are not equal or different. Okay, so what we can do to solve these is set up a proportion. So we're going to use proportions to solve these. So for example, if a tree casts a shadow if a tree casts a shadow 12 feet long and at the same time a person who is 5 feet 6 inches casts a 3-foot shadow, how tall is the tree? So this would be a situation where we can use similar triangles, because if this is happening at the same time, the angle of the sun is the same. So let's say I've got, here's the tree, and here's the shadow that it's casting, and then we've got the person casting a shadow kind of like this, making a triangle. So down here, angle A, those would be the same. So let's say the angle that's being made right there due to the sun in the shadow is looks like maybe, let's say, 50 degrees. That means with the person it would also be 50 degrees. Okay, so the dimensions we know: a tree casts a shadow of 12 feet long, so 12 feet for the shadow of the tree. That person who is 5 foot 6 inches casts a 3-foot shadow. So the person 5 foot 6 inches, I'm going to change this to 5.5 feet so that I have common unit. I can work with that. So the thing I don't know is the tree. So I'm going to set up a proportion. So if, a couple different ways I could do that, but let's say I do x over 12. So if I do the height of the tree, the shadow of the tree, then I have to do 5.5 over 3. Okay, so x over 12 equals 5.5 over 3. Either way, my next step when I do my cross multiplying, I should get 3x equals 5.5 times 12. 5.5 times 12. Or actually calculate what that is, which is 66, and then divide by 3. 66 divided by 3 is 22 feet. So, and that seems reasonable that the height of the tree would be 22 feet.